In this chapter, we're going to be discussing another data structure, the array. The array is similar to the list, except for one major difference, and that difference is that when you create an array, you have to tell the compiler the size of the array when you declare the array. And then once the array is set to that size, it can never change, unlike a list that can grow as you need it to. With an array, you're mostly limited to the size of the array when you declare it. So in this lesson, we're going to look at how to declare arrays. So let's start off by looking at a couple of examples. Let's say we want to create an integer array of numbers. The way we do that is we start with the data type, followed by a set of open and closed brackets, followed by the name of the array, we'll call it numbers, followed by an equal sign, the keyword new, the data type again, an open bracket, and the number of elements that you want, like so. So here I'm saying I want an array named numbers, and it will hold 100 integers. So I can work with another data type. I can write string names equals new string 10, boolean values equals new boolean 2, char letters equals new char 50, like so. Those are all valid array declarations. Just as with the list though, if we want to initialize our array to a set of data in advance, we can do that. I'll show you just a couple of examples here. For numbers, we could write int nums equals new int, and then after the open and close parentheses, I'll put a open curly brace, and then we can write our list, like so. I could do the same thing with characters. The thing to remember about a list is you have to delimit each element with a comma. I'll stop with this example because you get the idea. And then close the list and then a semicolon. So those are the two ways you declare arrays. Either with just the number of elements you want to store in the array, or with the actual list of elements themselves. And of course, that's telling the compiler how many elements to put into that array. When you're looking at the positions of an array, you always start with position 0, or we also call that index 0 or even offset 0. So that in my nums example here, the number 1 is at position 0, number 2 is at position 1, number 3 is at position 2, and so on. So the last element of the array, sometimes also called the upper bound, is always going to be one less than the number of elements in the array. And like with lists, that's important when we're looping through an array. We have to be very careful that we don't go beyond the end of an array when looping through it, because that can lead to an error. So again, those are the two ways that you can declare arrays, and we'll finish the lesson there, and we'll move to the next lesson where we're going to demonstrate ways to access and work with the elements in an array.